Okay, let's take a look at this. You earn $8 per hour, you work 25 hours one week, and 15 hours another week, okay? So you could, the two different approaches you could use, there it is this. Okay, I'm paid $8 per hour, so $8, okay? For the first week, I work 25 hours, so of course it's 8 times 25, okay? That's what it would be, that's for the first week. For the second week, I'm still getting paid $8 an hour, but I'm only working for 15 hours, okay? So that's what I would do, 8 times 15, okay? So that would be it. I mean, that's just me symbolically representing that. I don't have to work it all out right now. Now, how about, though, if I'm still being paid $8 an hour, why don't I just add those two together? I mean, what's my total hours? 25 and 15, well, that's 40 hours. But in other words, what we're saying is instead of doing it individually each week, why don't we just add those two together, because that's my total hours for those 2 weeks, okay? That's what I would do. Now I know that's 40, okay? So that would be it, because I work a total of 40 hours. But can you see what I've done here is this. Distributive law, 8 times 25, well there it would be. And then 8 times 15, with a plus in between, okay? So there's it, that's how it works, okay? That's you using the distributive property. Now, of course, for that one, I wouldn't do the distributive property. I would add 25 and 15 first. I mean, this one, think of, please excuse my dear Aunt Sally, but imagine if there were x's, okay, where you can't add them together. X's and numbers, remember you can't add. Anything down here. So there it is, here it is, look at that right there. There it is, okay? What we're saying is, if we have something like that, we can go A times B and A times C, okay, and there it is, right there. So, here's a good explanation, actually, down here. Right. What is the area of that rectangle? Okay, it's A times B, which is AB. Okay? Okay, what is the area of this rectangle? Right? Okay, well again, its width is still A, but its length is C. Okay, maybe I shouldn't have included that right now, because that's not for now. Okay, it's just C. Here's the length C. So if you add those two together, the area of the whole two pieces is this. Okay, so again, A times B for this one. I'll just kind of do this. Remember, it was going to there, and then A times C for this one. Okay, the two separate rectangles. Now, but supposing you just made it one big rectangle, then the length on the top is B plus C, okay? The B added to the C. If I did it as one long piece, okay? So I'd still go, okay, it's still length times width. Well, again, here's the A, the width still. What I'm multiplying by now is B plus C, this one and this one. I've added them together. B plus C. And again, can you see, look, A times B is AB, A times C is AC. Now, for future reference, also think about the fact that, you know, this one can become that one. Right now, we're kind of going this way, okay? We're kind of doing the distributive law to create it in expanded form, okay? We call it expanded form. Okay, now then, and that's basically what we've done here. Area for rectangle 1 was AB. Area for rectangle 2 was AC, just length times width for both of them, okay? But if you put them both together, then the whole length was, remember, B plus C. And again, when I still multiply by that little width, okay? So again, if I add these two together for the two rectangles, of course I'll get that. But when I do the distributive law, there's the AB and there's the AC, okay? And after that, I think it's just having to go at some examples. Let's have a look. Here's one right here. I won't do every single one. 2 times x, well, there it is. And 2 times 5, well, there it is. Well, I can do the 2 times 5, okay? There it is, 2x plus 10. That's it. Let's look at some more. Okay, now then. Now, if you want to do, if you know how to kind of do this straight off, then all you're going to do is do this, right? 4 times, was it 3x minus 5? 3x minus 5 in parenthesis. Okay, let's do that. A little bit better. 4. Okay, 4 times 3x. 4 times 3 with an x is 12x. It's got a minus in between. Let's on to that then, okay? And then 4 times 5 is 20. So that's what it is, and that's what it is down there if you just do the basic algebra. Okay, but now look at the explanation. Okay, I'm doing 4 times 3x minus 5. So all of this here, you can think of the one parenthesis, right? That's the whole length of it. But right now, supposing I just chop it in 2, okay? So this is just what's 4 times 3x, okay? 4 times 3x is 12x. This little bit, again, length times width, it's just the area of a rectangle. 4 times negative 5 is negative 20. And that's why, if you put it together as one big thing, the 4 times it, if you include the 3x with the negative 5, okay, in other words, the whole way along the top, okay, one long piece, that's why you'd still get 12x minus 20. So even if you break it into 2 little bits, okay? And after that, let's just see if there's any kind of examples we can look at. Here they all are, okay? So, 5 times x is 5x. 5 times 6 is 30. There's a plus in between, right? Now, what's this next one? What's negative 10x times a y? Negative 10x times a y. All I can do is negative 10x y. All these write them next to each other, okay? Negative 10xy. Now, be careful. Negative times a positive is a negative. What's negative 10 times 11? That's negative 110. Okay, just 10 times 11, and it's still got the x there, okay? That would be the answer for that one. That might be a little bit harder, all right? I think that's all we really need to kind of do. Let's just do some other ones with a negative. Supposing I say what's negative 5 x minus 3, okay? Let's keep it more simple. Negative 5 times x is negative 5x, and negative 5 times negative 3 would be positive 15, okay? So that would be the answer right there, okay? Negative 5x plus 15, and that's the distributive law, okay?